In this video we will find out how to add electric forces because forces are vector and they can have any direction. So let's see how to solve a problem based on this. So the first step is in this problem is we have three charges. You can see that there are three charges, Q2, Q3 and Q1, and the question is asking you, the first part it's asking you find the component of force F23 exerted by Q2 on Q3. So our charge which we have to focus on is Q3. We want to find out F23 in first part A. In part B it's asking you find the components of F13 exerted by Q1 on Q3. So again our focus is Q3. So this is our focus for this problem. We want to find out the forces on Q3, and then in part 3 it's telling you find the resultant force on Q3. So the first step we will write F13. Look at the diagram. F13, first step is to draw the forces with their direction. You can see that Q3 and Q1, they both are positive, so there will be force of repulsion. So F13 is acting away from Q3, okay, and Q2 is negative. Look at the charge, Q2 is negative, Q3 is positive, okay, so there will be force of attraction, and that's why F23 is towards left. So let's apply Coulomb's law for finding the electrostatic force for F13. You can see that it is KQ1 Q3 over R13 square. We substitute the values for K, Q1 and Q3 and R13 from the diagram. If you look at R13 from the diagram, it's 5 meter. The distance between 1 and 3 is 5 meter from the diagram, so we substitute that and we get the value for F13. Then we find F23 same way. We will apply Coulomb's law. This time it will be Q2 and Q3 and R23. We substitute the values. We look at the distance between 2 and 3, R23. This is R23. Distance between 2 and 3 is 4. We substitute that. We get the answer for F23. Now we are going to redraw the diagram with forces on Q3. You can see that Q3 is having two forces, F13 and F23, and from the diagram which is given in the question, F13 is making an angle of 36.9 degree with the x-axis. This is the x-axis. We already calculated the values of F13 and F23. F13 and F23 both are vectors. That's why we have an arrow placed on the alphabets. You can check the arrow. F13 and F23, they both have arrows. That means they are vectors. Now we are going to add vectors, which we have learned in classes in grade 10, how to add vectors. The same method we are going to apply, getting x and y component for both the vectors. X component for F13 is F13 cos 36.9 because x makes the angle, so it gets the cos. Y component will be F13 sin 36.9. Both of them are positive because x is towards right and y is upwards. F23 will be negative F23 in x direction. Negative because it's pointing towards left. You can check the direction, it's pointing towards left. And y component will be 0 because it does not make any angle. Next step is to find the sum. So F13 cos 36.9 minus F23 is the x component, total x component, total y component will be F13 sin 36.9. Now the next step is to substitute the values and get the x component, and similarly substitute the values and get the y component. Now we have to combine it to get F net. We know the formula using Pythagoras, that is root of fx square plus fy square. We know fx and fy values. Substitute that. We get the answer for F net. Now because this is only the magnitude, we also want to find the direction. direction tan theta equal to Fy plus Fi divided by Fx. Recall this we did in grade 10. We substitute the values, use calculator to get 65 degrees.